Welcome you all students. In this video lecture, I will teach you how to construct cycloid. Okay. Before that, I want you to remember the concept of cycloidal curves. In the cycloidal curves, namely three curves we had, right? One is a cycloid, and next one is a epicycloid, and next one is a hypocycloid. So cycloid in the sense, I said in the last video, when any circle rolls along the straight line path, that means a flat surface, the point on the circumference of the circle traces the curve, that is known as a cycloid, right? And when come to the epicycloid, I said it's a curve traced by the point on the circumference of the circle when the circle rolls above or outside another circle, right? The same manner I can say for the hypocycloid, it is a bit different from epicycloid. That means it rolls inside another circle. Okay, epicycloid in the sense rolls above or outside another circle. Hypocycloid in the sense rolls inside of another circle. That's a change. So I have a question for you. So once you had the question, you just understand the concept. Just read out the things and try to understand the concept, what it is trying to say. Okay, so I'll read out for you. A coin of 40 mm diameter rolls over a horizontal table without slipping. A point on the circumference of the coin is in contact with the table surface in the beginning and after one complete revolution. Draw the path traced by the points. Draw a tangent and normal at 30 mm from the base. Okay. See a coin of diameter 40 mm. Okay. So coin in the sense we are well familiar. That means coin in the sense a circular object. Okay, no issue. It rolls over a horizontal table. What it means? Horizontal table. That means it's a straight line path, am I right? It's a flat surface. So, crystal clearly we can grasp the thing. It's nothing but it's a cycloid. Circle is rolling on the straight line path. Circle is rolling on the horizontal platform, am I right? Same manner, sometimes you may get some other application oriented question. That means in order to the coin, you may get drum is rolling on the flat surface. Okay, sometimes you may get wheel is rolling on the road surface, something like that. You will be having a circular object and you will be having the horizontal table or else flat surface related things. If it not, we can conclude it's a cycloid. So now we have concluded it is nothing but a cycloid. Okay, so then we can take the given data. Here the circle diameter D, capital D is given as 40 mm. 40 mm as 40 mm. And next, any other things? No. Right. So first initially we must draw this circle. Okay, we must draw this circle. If it is a diameter 40, I can say radius as 20 mm. Initially, we must draw the circle. For that, you have to take the compass. You take the compass and read 20 mm in your compass. You have to measure 20 mm in your compass and place a point as a center and go for a circle so that we will get a circle as this manner. You have measured 20 mm in your compass in order to achieve 40 mm diameter and you are going for a circle. Initially it must be a thin line. You have to use 2H pencil to draw the circle because in the last only we will be concluding the record part and the unrecord parts. Okay, so first of all you go with the very thin line for which you have to take 2H pencil and go for a circle, right? Fine. So after that, having the circle, here is the center. So first thing is you must divide this circle into 8 equal parts. Okay, so for that, through the center you can draw a very good horizontal line with the help of scale. You have to use a scale and you have to keep like this, and you have to go for very good horizontal line. Okay, afterwards take your protractor. Our ultimate aim is to divide the circle into 8 equal parts, right? 8 equal parts. So keep the protractor as this manner. You have to keep like this and measure 90 degree, 90 degree, and go for a vertical line passing through the point, center point, so that you can divide the circle into 4 equal parts. Now we have 4 equal parts. We need 8 equal parts, so some more works are there. Same manner, the protractor you can keep like this. In this manner you can keep and read 45 degree. Read 45 degree as this. You can read 45 and go for a line passing through the center. You can divide it. The same manner in the other side too, you can measure 45 degree and go for a line passing through the center. You will get the circle divided into 8 equal parts. Okay, so now the rolling circle is ready. The rolling circle is ready. It's a cycloid. It is rolling on the horizontal table, rolling on the horizontal table. So we must ready with the platform, a straight line, nothing but a straight line. Am I right? Yes. So for that, we have to look the question. Here it is given the point on the circumference of the coin is in contact. The initially the point on the circumference of the circle of the coin, we have contact. Okay, in the table with the table surface in the beginning and after one complete revolution. That is notable. We are going to draw the cycloid for one complete revolution, one turn. For one turn we are going to construct. Okay, so in the introduction part itself I told you for one complete revolution, we must take the length pi into d. Pi into d, that means pi into d, pi into 40, pi in the sense 3.14 into 40. If you do the calculation, I can say you will get 125.6 mm. 125.6 mm. Okay, so next thing is we must draw the platform. For that, from this point you are going to draw a very good horizontal line. Very good horizontal line, should not be inclined. Very good horizontal 0 degree line. Okay, with the measurement of the circumferential length 125.6. 125.6. Okay, so now the line is ready. The same like the circle, we must divide this path into 8 equal parts. Okay, for that from this end you can have a 90 degree line. You can have a 90 degree line, and from the topmost point you can have a horizontal line, so that you will get a boundary. Will get a boundary of the platform, right? Afterwards, from each and every point on the circumference of the coin, you must take a horizontal line. If you take, I can say these 2 points, comes in a straight line, and these 2 points comes in a straight line. If you take a line, horizontal line, these 2 points will comes in a straight line. Okay, and next we are going to divide this pi into d distance into 8 equal parts. Okay, same like the rolling circle. For that, we are going to use the bisection method. So this is the one end and this is the another end. This is our rectangular box. Am I right? This is our rectangular box, right? So this part we are going to divide it into 8 equal parts, right? So that first you have to take more than half of this portion. This is our exact portion. So take more than half of this portion and go for an arc. You are taking more than half in your compass and going for an arc. The same manner with the same measurement. Okay, keep on the other end and go for an arc. Keep your compass on this end with the same measurement. How to go for an arc? Okay. Afterwards, just drop a very good perpendicular line. Just drop a very good perpendicular line, so that see this part is divided into two equal parts. So again we have to divide. So this is our exact part. Now this part we are again going to divide it into two. Okay, so here one and here one. So this is the exact point parts we are going to divide again. So take more than half of this portion. Take more than half of this portion in your compass and go for an arc. Go for an arc and keep with the same measurement from the other end. Have an arc and drop a line. Drop a line. It should be perpendicular. It should be perpendicular, so that this part's divided into two equal parts. The same manner, this part take more than half and go for an arc with the same measurement. Keep at the other end and go for an arc. Drop a line, 90-degree line. You can divide it into equal. So now we got 1, 2, 3, 4 equal parts. Again, our aim is to divide it into 8 equal parts. So this is our segment. This is our segment. Take more than half and go for an arc. Keep at the end. Go for an arc. Drop a line. You will get two equal parts. So this is our segment. So take more than half of this segment and go for an arc. On the other end, go for an arc with the same measurement. You will get a line. Same manner here. Go for more than half. Have a cut. And then just drop a line. You will get a line. The same manner here you do it, so that you can divide it into 8 equal parts. So we are ready with the divided circle and divided platform. Okay, so the next step is we want to give the notation. That is that plays a very important part here. If you mark all the notation in a right manner only, you will get the curve. You can easily identify the trace out. So for that you are going to move this circle in the forward motion. You are going to get the forward motion. So you will be rotating the rolling circle in the clockwise direction. This is a clockwise direction. So here is the circumferential point, right? So what I'm going to do is, here is the contact point. From the next circumferential point, I'm going to give the number. So I'm going to take this as 1, and this as 2, and this as 3, this is 4, this is 5, 6, and this is 7, and this contact point as 8th one. It's the last one. Okay, you can remember like this. Our circle is going to rotate in the clockwise direction, and your notation in the circumferential point is going in the just opposite, anti-clockwise direction. Okay, so your circle is going to roll in the clockwise direction, and you have denoted all the circumferential points in the anti-clockwise direction. Okay, fine. And the same manner in the point to distance also, they have to give the naming. I'm going to take the first point as 1 and second as 2. This is 3. This is 4. Since it is given 1, 2, 3, and here we can give quite different. That means 1 dash, 2 dash, 3 dash. This is 4 dash. This is 5, and this is 6 dash. This is 7 dash, and this is 8 dash. Now almost we have completed the construction work. Almost we came to the end. Now the part is we must identify the trace. That means we have to identify the path traced by the point on the circumference of the circle. Okay. So for that, so we must note the locus of the center here. Okay, you must note the locus of the center. So this is the center of the circle. This is the center of the circle. So this point, that means the first one dash is coming the intersection with the C locus. So we can take this as C1. Okay, and here 2 dash is coming and it is intersecting. We can take this as C2, and this 3 dash is coming and intersecting. This is as C3, and 4 dash is intersecting. This is C4, C5 intersecting. We can take that point as C5, and here it is C6, C7, and this is our C8. Okay, so now we can trace the point. For that we have to take the measurement of the rolling circle. That means you have to measure with your compass. From this reference you can take the rolling circle radius, because this rolling circle only going to roll in the straight line path. Am I right? We are going to trace out the point on the circumference of the circle. Always, if it rolls also, the measurement will be constant. Whenever it goes to any position, the measurement will be in the same distance. Am I right? So how to measure the radius of the rolling circle in your compass, and to find out the first trace point, how to keep at the C1, and you have to look for the first line. How to look for the first line. Here is the first line. Here is the first line. Keep at C1 and go for a cut mark. Go for cut mark. You have measured the radius of the rolling circle, and you have kept the center as C1, and you are looking for the line. Looking for the line 1, and have made a cut on that line. Right? Then with the same measurement, radius of rolling circle, you need not to change your measurement. Just keep at C2 and look for the second line. Keep at C2 and look for the second line and go for a cut mark. You will get approximately here. Right? And keep at the C3 with the same measurement. Look for the third line. Third line is coming here. Go for a cut mark, so that approximately you will get an arc here. And next, keep at C4 and have a cut mark in the fourth line. You will get this as a maximum. This is a maximum point. And next, the same procedure we have to follow for all the remaining points. You are keeping the center C5 as a center with the same measurement rolling circle as a radius. You are looking for the fifth line, going for a cut mark. Same manner in the sixth, you are going for a cut mark in the sixth line, and you are keeping the center in the C7 and going for cut mark in the seventh line, and keep C8 as a center. Go the cut mark in the eighth line, so that you will get the last point here in the 8 dash. Okay, so it's starting from the 8 and reaching the maximum in the fourth point and coming to the minimum in the 8 dash. Okay, please remember it. It is starting from 8, reaching the maximum at 4 dash, and again it's coming to the minimum point at 8 dash. If you joined all those picked point, you could evidently see the formation of this cycloids. Could see the formation of cycloid. Once you are very strong enough to conclude this is the exact cycloidal shape, you can take the 2H pencil or HP pencil. You can take the HP pencil and go for very dark line, because this is the exact required part. You are asked to draw this curve, right? So this is the cycloid curve. So we have to make as much darker with the HP pencil. Okay, and next we can give the point numbers. So this is the first point. Take this as P1, and here we have the cut mark P2. So here is that, so you can take this as P3, and here is a P4, and here we have the P5, and here we have P6, and here we have P7, and here we have P8 point. Fine. See, we have drawn the what? Cycloid curve. And next thing is path traced by the point is almost completed, and next one more question is there. Draw tangent and normal at 30 mm from the baseline. Draw tangent and normal at 30 mm from the baseline. See, this is the rolling circle, or else we can say as a generating circle. And when you come to the straight line, we may call as a baseline, or else we may call as a directing line. Am I right? Baseline or directing line. So this straight line is the baseline. You don't want any confusion. This baseline in the sense nothing but the straight line. Sometimes they may tell like directing line. That also possible. So see, from the baseline 30 mm, we must draw the tangent and normal. So for that, how to take the scale? You just note 30 mm. Approximately I am taking this is my 30 mm. Approximately I am keeping this is my 30 mm. Okay, this is my 30 mm. And what you have to do is, this is the baseline. From the baseline, how to move, you have to keep in vertical manner, like this manner, and you have to move like this. So when you are moving, you will get a contact point in the curve. You have taken a 30 mm and just you have placed the scale in the vertical manner, and you are just moving like this, and while moving you got the contact point. That point have chosen for drawing the tangent and normal. Okay, so afterwards this is the point. Here I going to draw the tangent. You take the compass, and again measure the radius of the rolling circle. Keep one leg of your compass on this chosen point and go for an arc in the locus of the center. So just have a cut mark with the rolling circle radius. So you got the point here, and just drop a very good vertical line to the directing line. What you have done, you have taken 30 mm from the baseline, and you had a point, and afterwards you have taken the rolling circle radius in your compass, and you have placed in the chosen point, and you went for an arc in the locus of the center. Okay, so you got the cut point. From that you have dropped the line to the straight line, which should be perpendicular. So there you got a point. Am I right? There you got a point. That is nothing but n. From that n, you have to connect the chosen point with a scale. I can say this is your normal. You can denote as n and n dash. This is your normal. In the parabola, hyperbola and ellipse, we used to get, at first we will be getting the tangent and normal, and then we will be getting the normal line. Here in the cycloidal curves, initially we will get the normal, and after finding the normal, we will be going for the tangent. So to draw the tangent, what you have to do is, how to take the protractor, and you have to just take 90 degree and just pause a line to the outer periphery of the curve. You are taking 90 degree in your protractor, and you are going for a straight line, just passing through the outer periphery of the curve. So that we can mention this as T dash. So in this diagram, our cycloid curve should be a dark one, and normal and tangent should be a, a dark line. Okay, so afterwards we have to do texting and dimensioning. That's the important one, important work. So for that, see, we have mentioned the pi into distance well, and next rolling circle diameter is there, that must be also captured in the diagram. So for that this is the diameter, right? So from each end you can take a extension line, you can take an extension with a thin line, and you can draw a vertical line with the ends carrying arrow mark, a filled arrow mark, and write pi 40 as diameter in above your dimension line, right? And afterwards one more dimensions markings we done, that means 30 mm from the baseline, right, that must be shown. So here is the point. So from this you can take a extension line, from this base you can take the extension line. Okay, afterwards you can have the vertical line, you can take a filled arrow marks, you can write 30 mm. Okay, so almost our dimension work over, and afterwards testing how to do, for that I'm going to write here. So we know the procedure. Whenever we are doing the testing work, we must open the guideline with uh, 5 mm gap, So first, see, we have noted the n dash, which is nothing but normal, right? So that must be captured here, n dash as normal. Okay, and next tangent. So t dash as tangent. And then we have to write all dimensions are in mm. So for that you can open a 5 mm gap guideline, and you can write all dimensions or in mm. or in mm. Sometimes in the question they will be adding name the curve, something like that. If they ask to name the curve in the top or in the rightmost end, you can write this curve is an cycloid, something like that. Okay, so thank you. I'll be coming with the next video. Thank you so much.